The second part of the chapter 5, we go to the keypad. Okay, this is example of the keypad. How it function? Actually, you just push button, connect with several resistor. Here we have resistor. For example, if you push button number 1, it will connect RC7 going to connector with RC3, and then here is the voltage. Don't need to understand so much because nowadays we have library. Don't need to, if you do the by using the IC microcontroller, is quite complex because you need to have configuration. You don't have the library for LCD. So this is how it functions. It connect with the two wires, and then every time button press, two wires connect to each other, and then here is the keypad matrix row and column. Alright, so this is the, if you open Proteus, you will have this type of keypad. In the lab also almost similar with this type, but because it a little bit hard. Okay, now it's still using the common type of LCD. And then how LCD connected, you already know. For this configuration, we are using A0 until A5 for the LCD because the keypad, it will use 8 pins of the input or the output. So since we are using digital pin for the keypad, we use analog pin on the LCD. Okay, you made it. This one is simple technique. You have 16 keys of matrix and then key decoded column and row. It's okay, don't need to understand detail about it. I will go direct to the simulation. This is how it connected. You can see here you have 8 pins connected to the pin 2 until pin 9, and then all 6 pins of the analog connected to the LCD. This is the command. Here liquid crystal.h for the LCD library, keypad.h for the keypad library. Analog, liquid crystal connected. This one similar like previous one. Analog input, no, LCD pin. We start with RS, enable D4 until D7, and then this one constant byte rows and columns represent how many keypad you have, how many rows and how many columns. And then character keys, rows, column. This is actually, this one we declare as an array, two-dimensional array if you still remember C++. And then this is the pin we set up, 7, 8, 9. We will follow whatever pin you have here. Okay, this is character variable declaration. And then we have here row 2 and row 3 for Arduino pins. What pins you connect for the rows, for the row, and for the columns. Depends to the connection here. Row, columns. A, B, C, D is the row. 1, 2, 3, 4 is column. Next, keypad KPD. KPD is just variable. You can name whatever you want. Equal to keypad. This one you must follow. Make keypad keys, rows, pins, columns, row, column. This one you just copy. It will refer actually for the keys here. Keys you variable two-dimensional array you have declared. Now we go to void setup. LCD begin, same. LCD print, keypad LCD test. You can print whatever you want. Now we go to the void loop, which is the main function here. Character key equal to keypad KPD get key. Get key is the command. KPD depends to whatever you write here. Keypad KPD. If you write KPD2, then use KPD2. Later we will discuss details during simulation part. LCD pin sequence directly display LCD. LCD set cursor 01, you know LCD previously. LCD pin millis times 1000. This divide by 1000. This one to represent second. Millis is the function to measure time, real time. Divide by 1000 to convert from millisecond into second. If key represent whatever you write here, the key input. If key LCD set cursor 9 is 9 columns, 1 is the bottom row of the LCD print, key equal to LCD print key. Key represent whatever input you write here for the keys row and column. Okay, that's all. Thank you. Bye.